Hello. Let's run a simple regression to predict the future. Here is our data. The historical home price in the US until 2018. We want to know how is the home price going to be in the future. 3 or 5 years. The shortcut to run a simple regression is this way. Choose the data, all the data including the headers. Click Insert tab. Choose Scatter Plot. Oh, we have the scatter plot for the data points. Looks nicely. Let's move this graph to here and make it bigger. Click one data point in the graph and choose Add Trend Line. Linear and forward to future 3 years, 3 periods, and choose displayed equation, displayed R squared. I want to point out that don't choose set intercept. Okay, looks nice. We have the linear model here. This is the R square. What is the R square? R square is coefficient of determination. It measures the goodness of fit for a model. The closer to 1, the better. Look at the R square here is almost very close to 1. That's very good. And we got the equation, linear equation here. But what is this number? This is Excel version of scientific notation. Actually, this is 1 times 10 to the 7th power. This is the shortcut to run a simple regression. The formal way to do it is use data analysis toolpath. Let's click data and go to data analysis and choose regression and click OK. Input range Y. Dependent variable is home price. Input S range. Independent variable here is the year. And we check labels because we put a header in here. So confidence interval level 95%, and new worksheet. Give the new worksheet a name. Don't choose this. We click OK. Okay, we have a new sheet. And let's make it bigger. Go to Home. And bigger. And then Format Auto Fit Column. Okay, let's go through this information. The most important is check the adjusted R square. The closer to 1, the better. And also the significance F, because the confidence interval is 95%, and so the significant level here is alpha equals to 0.05. So actually this one, the smaller the better, the closer to 0 the better, at least less than 0.05. Obviously, this significance F is very small, 10 to the negative 38 power. Because it is very small, we are going to reject the null hypothesis here. The null hypothesis here is the linear model doesn't fit the data pattern. Reject it. We accept that linear model is fitting for the data pattern and very good fit. And also go to here, this p-value. Eyeball this p-value, the closer to the 0, the better. At least less than 0.05, because the hypothesis here is assume the coefficients, these two coefficients, respectively equal to 0. So because the p-value is so small, less than 0.05, we reject the hypothesis here and accept all the coefficients are these two values. Okay, we have the coefficients here. That means we are going to have our linear equation. Actually, we already have our linear equation here. Let's make it bigger. Oh, how could I cannot make it bigger? Okay, that's fine. The next step is to make prediction. Because we have the equation here, let's evaluate the equation for predictive value in 2019. 5578.4 times S is 2019 minus, I want to point out that here the Excel just run the coefficient to big one, to an integer, but actually is this value. So we need to use the accurate value here, 1.097251 times 10 to the 7th power, and then return, and then we just need to drag down. We have 3 predicted value for 3 future years home price. Are these prediction value make sense? Let's check with the real data here, because in 2018 the home price already over 300,000. but the predictive value here is lower. This two is lower 300,000. It doesn't make sense. So the 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 linear model here is a very good fit, but the predictive value do not make sense. Let's go back to the outcome information to check. This is the middle predictive value. Look at this lower bound, upper bound. That means actually the intercept fall in this interval, and the year fall in this interval. So we can use one number in this interval to adjust the prediction. Like here, for example, if I just change this one to be 0.9 and then evaluate it. Oh, we got a pretty good predictive value, and we check this value, and with the past data, it makes sense. Another way you guys might interested in exploring is use another kind of model to predict the future. In order to avoid a very big number, to make the prediction calculation simpler, I just put the period number in corresponding to the year. And then I choose these two columns. Insert scatter. And then add trend line. Look at here. Just add trend line. We have lots of options here. Let's check everyone. Point action line. Try exponential. Let's delete the linear. Delete the linear. Yeah. Action line. Polynomial, and then power, and then logarithm. Okay, looks like the polynomial fits pretty good. Let's check here. This is exponential. Just delete this one. Oh, looks like my mouse has some dysfunction here. Okay, let's try polynomial and further to future 3 years and display the equation, display the r square. This is the polynomial. And then after having this equation, we just evaluate this equation and predict the future 3 years home price. We got this 3 predictive value. It looks much better than the linear modern prediction. That's all.